Okay, norepinephrine and epinephrine are involved in fight or flight. Okay, so fight or flight response, it's kind of easy to remember because fight and flight kind of sound similar, and norepinephrine and epinephrine sound kind of similar. So it kind of goes together in my opinion. Fight or flight is part of the autonomic nervous system, remember, because it's automatic, and we'll get into that in a second. Also linked to depression, but more so serotonin, so don't worry about that too much. And I would leave it at that. When norepinephrine's up, your heart rate and your blood pressure is up. Remember that test question I gave you where they said that norepinephrine levels and dopamine levels were increased, and you had to figure out what kind of drug it was, and it was a stimulant. Remember that one? Mm-hmm. on the consciousness test. So you could see norepinephrine, heart rate, and blood pressure up. So with dopamine, you know, and all that stuff, you being like crazy, I can conquer the world. Remember that one? Mm-hmm. Stimulant. Okay. All right. GABA. Inhibitory. GABA. You want to inhibit that show because it causes you anxiety. So if you don't have enough GABA, you get anxiety. Okay? So GABA kind of like stops your anxiety. It inhibits it. So I know the GABA thing kind of is confusing with that. So so without enough GABA, your anxiety kind of runs wild, and so you need GABA to sort of calm it down. Otherwise, you're constantly in fight or flight, and that creates anxiety. Okay? Okay. Cool. Can I move on? Glutamate, also possibly linked to schizophrenia, but it's more likely you'll have a question linking dopamine to schizophrenia. Learning and memory, you're probably not going to, you might be tested on glutamate, but probably not. ALS or Lou Gehrig's disease is linked to an excess amount of glutamate, which could be toxic, which could lead to muscle weakness and paralysis. Again, this is one of the really serotonin, dopamine, acetylcholine, GABA. Those are like the main neurotransmitters I think that you'll likely be tested on. Glutamate's a possibility, but endorphins is also another one, which is coming up. So endorphins, remember pain relief, like opiates. Okay, runner's high, that's endorphins. All right. Morphine is an agonist. Okay. Still going, Elizabeth? All right, so within your peripheral nervous system, you have the somatic nervous system and you have the autonomic nervous system. Somatic is voluntary, autonomic is automatic or involuntary, right? So within the somatic, you have the same neurons. So the neurons going from the outside world to your brain are what? Sensory or afferent, right? And the ones going from your brain to the outside telling you to move your muscles, motor or afferent. Good. Okay. Within your autonomic, you have, remember autonomic is automatic, involuntary. You have the sympathetic and the parasympathetic nervous system. During an emergency, you want sympathy. So the sympathetic operates during fight or flight. Okay? The parasympathetic, what are you doing?
Conserving energy.
Conserving for an emergency, right? Like parasympathetic for the sympathetic. So that's during non-fight or flight. You're just saving up your resources. Okay? So during fight or flight, your pupils dilate, your heart rate goes up, you're basically ready for running and ready for running, which is flight, or ready for fighting. Okay? Digestion's inhibited. Your bladder's relaxed, apparently, so you can make yourself lighter. Okay? Any questions? You don't have to know every single thing, but I think heart rate going up and pupils dilating. Increased respiration, those are the main things, okay? What measures this stuff? EEG, good. So EEG measures brain waves. They do it during sleep research and other things. TMS, transcranial magnetic stimulation. They put your head in a thing, okay? And there's a magnet, and it targets a specific area in your brain. So it could either increase or decrease the firing of the neurons. And then when they take you out of the contraption, you're back to normal. So it's kind of cool because it can give you like virtual lesions. For a time, if it suppresses neural activity, it's as though they removed that part of your brain. And so it's really good for conducting studies because they could find out like, oh, you know, that part of the brain is, if that part of the brain is missing, what sort of things can they no longer do, all right? Even though they're not really cutting into the brain, okay? So that's and then they could also increase firing too. Transcranial magnetic stimulation. The downside is they can't go deep into the brain yet. It's sort of just on the surface, but I'm sure, you know, eventually they'll be able to go deep into it too. It's been shown to be able to treat depression too. They found lesioning where they actually physically destroy a piece of brain tissue. So for example, the patients who were suffering from epilepsy, what did they do? They cut the corpus callosum, right? And so that's considered a type of lesioning because you're cutting out a part of the brain, right? If someone were to receive a lobotomy, part of their brain being taken out, that would be lesioning. Well, yeah. Yeah, it'd more so be a lobotomy, but I guess that's lesioning. Okay. ESB, electrical stimulation of the brain. Remember James Olds and the mice? Where he stimulated their hypothalamus when they pushed something, right? The lever. What did they keep doing? Right? They didn't care to eat or drink or anything. They just kept pushing the thing because it was giving them pleasure. It kind of shows you the effects on drugs, right? If you keep stimulating your dopamine to be released, you don't care about anything else, right? So it shows the effects of drugs. It's kind of scary. A CT scan or a CAT scan, same thing. You're doing cross-sectional x-rays, a bunch of x-rays, and then all those images are put together, and so it appears like a 3D, okay? They use this in finding like tumors and stuff like that. Also like mental illness, they'll notice some differences in brain structure. So this is something that shows structure of the brain, okay? They found with schizophrenics, and we'll go over this in chapter 15, where their ventricles tend to be enlarged in many of the cases. They might also have a smaller thalamus than the average person. Remember, the thalamus is like the relay center. It's where all the messages get sent out.
Is it 3D?
It kind of shows, yeah, it ends up giving you a 3D image, yeah. Okay, here it is. Those are the ventricles, the butterfly-looking thing. That thing is probably like a tumor or something. The red thing in the middle. Okay. PET scan shows brain function. So if you're in a device, and so a CAT scan, you go in, they do the pictures, you have a thing, and it shows the image of your brain. It's a CAT scan. It's not changing. It's just here it is, like an X-ray, right? A PET scan, you're in it while they look at it, and they see movement in it. Okay, so they might watch it while you do a task, or they might watch it, you know, I don't know, like if you talk, then they'll see other parts light up. That shows brain function, okay? So a PET scan shows brain function. What it does is it kind of shows where the blood flow is going to, and so if they see a lot of blood going to one area, they'll know that part of the brain is being used, okay? They also use it for like finding cancer and stuff because blood tends to go toward like tumors and stuff like that, so they'll look at it that way also. They're very, very, very expensive. Yeah. Okay. It's a PET. So PET shows function. Do you remember the other one that shows function? fMRI. Yeah. Okay. So there's the MRI, which shows structure, and the fMRI, which means functional MRI, which shows function, just like the PET scan. And the MRI is similar to the CAT scan, but it uses like magnetic waves. Okay? I think the CAT scan gives you more radiation, is the downside. Alrighty? Hi.
The coffee wagon is here if you've got a cup.
Oh, I'm okay. Thank you, though. Anyone want coffee?
I miss a coffee.
Coffee wagon.
Oh, wow.
Okay. Hey.
1 o'clock? 12 o'clock?
supposed to be 12, but I think we're gonna go a little over. Yeah, maybe, I don't know, 12:20? Is that, can you guys stay, or?
Yeah.
Okay, if you can, great, if you can't. Not your fault. Is it still going?
Yeah.
Okay. Alright, so we get MRI, fMRI. Alright, so parts of the brain. Hindbrain, the oldest part, contains the pons, the medulla, and the cerebellum. What does the pons do? Sleep and arousal. What does it do during REM? Paralyzes you. Good. Unless you have RBD. RBD. Okay, REM sleep behavior dyspnea of somnambulism. No, that's not during REM. Okay, so RBD, REM sleep behavior disorder, this is where you act out your dreams. So your pons isn't working properly because you're not being paralyzed, right? The medulla is in charge of what? Breathing, heart rate, vital life functions. Okay, this is why in the movies when they, aim for the medulla. Okay, cerebellum. Fine motor skills and balance, right? Good. That's the hindbrain. Questions? Okay, the midbrain is basically the thalamus. What does the thalamus do? It sends the messages. So remember, like you see something, it first goes to the thalamus and then to the occipital lobe. You smell something, it goes to smell your earwax.
Yeah. Taste
The
your
temporal lobes. You taste something,
forehead. And
taste your forehead. Okay, so it goes to the frontal lobe. And what's the part of the frontal lobe it goes to? Yeah, but what part of it? The insular, isn't it the insular cortex and the frontal lobe, I think it's called. Insular cortex. Sounds familiar. Okay, I don't know if you'll be tested on that. All right, and then the reticular activating system or reticular formation or ARAS. Arousal, it's in charge of waking you up. So if that gets damaged, you won't wake up, okay? That might account for like comas and stuff, if there's pressure on that, how you would stay in a coma. Okay? Okay. The forebrain, what's the big part of our forebrain?
The cerebrum.
Cerebrum. So all the lobes, those are part of the cerebrum, okay? The frontal lobe is the front of the cerebrum, the occipital lobe is the back of it. Because, right, the occipital, like, when you see something, it doesn't go to your cerebellum. It's still all within your cerebrum, just the occipital lobe, okay? So the cerebrum is the thinking, the, higher functioning, like humans have really large cerebrums because, we have like higher functioning problem solving skills. All right, also within the forebrain, you have the thing that connects the two hemispheres, corpus callosum, okay? And then you have this thing, that's in charge of emotion and stuff, limbic system, and then you have, I always forget which is which, but one of them's in charge of fear, amygdala, and then one of them is in charge of consolidating memories, hippocampus, okay? Turning short-term to long-term memory. When we go over the memory chapter, when we get back from break, it'll be mentioned again, okay? The gland, pituitary gland, and then above the below the thalamus is the hypothalamus, which is in charge of what?
And endocrine system.
The pituitary, which is the endocrine, and the 4Fs. Fighting, fleeing, feeding, and mating, okay? Alright, so, and it's in charge of the pituitary gland, and remember Pitbull is the master. So he's the master of the endocrine system, okay? Cool. Alrighty. Remember the pineal gland?
Yes.
What was that in charge of secreting?
Melatonin.
Melatonin, to regulate what? Circadian rhythms and sleep, yes. Okay? It's all coming together, yay. I think we got all of the brain, right?
Yeah.
See, the brain's like nothing now, right?
Yeah.
Alright. That's a real brain.
It's so gross.
I wonder if I could get some kind of grant where we